Hey everyone, I'm back with another problem on the InterviewBit series. So the problem today is maximum absolute difference. So you are given an array of integers of size n. You need to return the maximum value of f of ij for all I starting from 1 to n, and f of ij is defined as mod of ai minus aj plus mod of I minus j, right, where mod denotes the absolute value of x. Right. And the problem constraints are the length of the array can be from 1 to 10 to the power 5, and the elements inside the array can be positive, negative, and can range from negative of 10 to the power 9 to positive of 10 to the power 9. Okay, let's move on to a test case. So we have 1, 3, minus 1 here. So this array is of size 3. So n is equals to 3 here, and here the maximum absolute difference is equals to 5. So what is the maximum absolute difference? It is defined as mod of ai minus aj plus mod of I minus j. What is ai minus aj? Ai minus aj is ai and aj are the values at indices I and j, and I and j are the indices, right? So, the one quick approach which comes to our mind after seeing two elements and two indices is two for loops, right? So, you can maintain actually two for loops and calculate this value for all the possible pairs of I and j, right? You can have two for loops and calculate for all the pairs of I and j, all pairs of I and j, and then you can calculate this value for all the pairs and take the maximum. In that case you'll get the answer, right? But what would be the time complexity for this? So the time complexity for this is going to be big O of n square, right? But the main point here is, how do you optimize this? How do you bring it down, right? So let's just first open this mathematical expression. I don't want it to be looking like this, right? Let's try to open this mod. If I open this first value or the first modulus, I can have two possible cases. If ai is greater than aj, then the mod would come up with a positive sign, right? So you must have studied about mod. So mod x has two values. It starts with positive x and negative x. If x is positive or greater than 0, if x is negative, the mod opens like this, right? So you have two possible cases over here, right? So if I open this, I'll get two set of values. The first one being ai minus aj, and the second one being aj minus ai, right? And similarly, if I open this, so I'll have two possible options, I minus j, and the second is j minus I, right? So now if you look closely, if this first term has a value of this, so we can pair it with this and this, right? And if it has a value of the second one, then we can pair it with this and this. So we get four set of values, right? So we get four set of values. So let's just try to write each one of it. So the first one is ai minus aj plus I minus j, and the second one being ai minus aj plus j minus I, right? And the third one being aj minus ai plus I minus j, and the fourth one being aj minus ai plus j minus I, right? So let's properly write this. So this becomes, if you properly write it, so it becomes ai plus I minus, if you take minus common, you'll get aj plus j, right? And here if you write this properly, you'll get ai minus I, and let's take negative common again, so it becomes aj minus j. Let's write this. So this becomes, if you take negative common, it becomes minus of ai minus I and plus a of j minus j. And similarly, this becomes, if you take negative common, this becomes ai plus I plus aj plus j. So we have written down all the four possible conditions in a better format, right? So if you take a closer look, can you say that the first value and the third value, sorry, the first value and the fourth value, the first value and the fourth value are sort of similar? How is it similar? It has ai plus I, aj plus j, ai plus I, aj plus j. Only difference here being that this here this term is negative and here this term is negative, but it doesn't matter. Why? Because you can treat I and j as j and I, because it doesn't matter how we take the order of these indices, right? Perfect. So now similarly you check 2 and 3. So these are very similar conditions, right? So this whole four conditions can be broken down into just two conditions. And what are they? It would be ai plus I minus aj plus j, right? So the first condition being this, and what is the second condition? It would be ai minus I minus aj minus j. So the whole problem is broken down into just two condition, and that's it, right? So we just need to take the maximum of both of these conditions to get our answer. So how do we calculate these? How do we calculate these? It's simple, like, right, we have to iterate. So if you take a closer look, you need to get, if you want to maximize first, you need to maximize this term and you need to minimize this term, and similarly here as well, you need to maximize this term and you need to minimize this term, right? So how will we do that? We'll simply iterate over the array and we'll maintain four set of values, which is max 1, max 2, similarly max min 1 and min 2, and we'll try to fetch all the possible values for these, right? And at the end we'll take the maximum of max 1 minus min 1 and max 2 minus min 2, right? Perfect. Now let's move on to the coding part. Let's code it up real quick. So we are given this array a, so let's first get the size. N is equals to a dot size. Now we'll maintain four variables, which two for the maximums and two for the minimums. So int maxi1 is equals to int min and max2 is also equals to int min. Similarly, two for the minimums, int max and min2 is equals to int max. Now we'll simply iterate over this array, right? And we'll check. So maxi1 is going to be the maximum of maxi1, and I need to get the maximum of ai plus I, right? And similarly I need to get the minimum for this as well. So this would be min of mini1 and ai plus I, right? Similarly I'll maintain a maxi2, which is going to be the maximum of maxi2 and ai minus I, and mini2 is going to be the minimum of mini2 and ai minus I, right? That's it. And at last we are going to return the maximum of, so the first possible answer is going to be maxi1 minus mini1, right? Maxi1 minus mini1, and the second possible answer will be maxi2 minus mini2. So that's it. Let's run it. Okay, the trivial cases are passed, so let's submit it. Yeah, so it is accepted. So this solution was a linear solution, as we have only traversed through the array once, and we haven't used any external space, just variables. So the space complexity is also constant, so the time complexity is big O of n and the space is O of 1, right? I hope you understood this problem. I'll meet you guys in the next video. Till then, take care. Okay, chalo, bye.